Hello everyone, a very warm welcome to day 5 of our 2-week Engineering Conclave, Rethinking Engineering Futures. We have 3 engaging keynotes lined up covering knowledge representation in AI, human-centered design in engineering, and the future of AI in risk management for infrastructure. Our first keynote speaker this evening is Dr. Patience Usoro Usip, Associate Professor of Computer Science and Acting Head of Department of the University of Oyo, Nigeria. She specializes in knowledge representation and reasoning, with particular interest in formal representations using ontology and knowledge graphs, neurosymbolic AI, and intelligent systems. Her research spans applications in health, agriculture, and prediction systems. She has participated in numerous international conferences as a chair, publicity chair, and a committee member, in addition to editing and publishing books, chapters, and journal articles. Dr. Usip has been a recipient of multiple fellowships and grants, including the TETF Fund, IBR Grant, and All Africa House Fellowship at the University of Cape Town, and two
I can't
World
hear you.
KG Curation grants from the TIB Lab. Let us begin. Over to you, ma'am.
Sorry, I don't know. I'm not hearing anything. I've done what you said.
You are now muted. Are you able to hear me now? Hello?
Okay, I think we can get started. I'm sorry for the delay during the technical itch. Today, I'm speaking on the topic knowledge representation. as the bedrock of today's innovations. I'm speaking to you today is Dr. Patience Usoro. I am an associate professor of computer science, University of Uyo, Nigeria. I'm the founder of Fork Research Lab, University of Uyo, Nigeria. I'm a board member of and grantee, two-time grantee of ORKG TIB Lab, Leipzig, Germany. I've been a postdoc, an MIT TT postdoc fellow, and I've been an All Africa House Fellow, University of Cape Town, South Africa. Today I have the privilege and honor to speak on the topic knowledge representation as the bedrock of today's innovation. So let's get going. My outline is as shown here. So I'll start by introducing and then running around what knowledge representation is and the formalisms and why the ontologies and how reasoning is done, and I will stop by to show you a brief of some of the projects we've undergone in Fork Lab, and then I'll wrap up and conclude. So I'll start by looking at today's era, what's going on, and then the fact that innovation is what drives the progress of any country, any institution, any individual, any researcher, or even the community at large. Everything is driven by innovations. And we know for sure that computer science is a problem-solving tool where several models, such as even machine learning and some innovative models, are put forward and are used in driving these innovations. We also know that artificial intelligence today has been the forerunner of most of these innovations, and I made to the part of my late Bloomberg professor that artificial intelligence is the construction of architectures that deploy constraints exposed by representations that support models of problem solving. And so today we are anchoring on something. We saw in that definition that that representations will expose the constraints used in most of these architectures as adapted in the models problem solving. And so we have seen that knowledge representation and reasoning is a key branch of symbolic AI. And when we are talking about machine interpretable representations of the world, looking at a situation where how do humans reason? Can machines reason like humans, which is actually the drive which artificial intelligence came up with? And this reminds me of what Patrick Winston called his gold star idea. He said, when getting representations right, you are almost done. So for any innovative ideas anyone will pick on today, we know that knowledge representation is an underlying force that will get the ideas to be achieved. And so today's innovations are expected to enhance the artificial intelligence capabilities to make systems more intuitive and effective in various applications. Today, we have several AI-based applications. Most of today's innovations across various fields are AI-based. And their main intent is to enable machines to understand, reason, and interact with human knowledge. There are several basic terminologies which we can't do without when we're talking about knowledge representation. We know that we can't represent anything except we have the knowledge. Knowledge forms the bedrock upon which ideas are built. And knowledge representation in itself is an act of storing and manipulating information, encoding that information about the world in a format that a computer system can utilize and solve complex tasks. And we can do this based on logical and probabilistic representations. We can do this if we reason with what has been logically constructed, represented. We can infer new knowledge. We can use the stored information to answer basic questions and draw new conclusions. But firstly, this knowledge must have to be stored. They must have to be structured in a way that reasoning is made possible. And so problem solving, whether it is planning or searching, any generic problem solving architecture is based on ideas from cognitive science, such as game playing, robotics. And today, the big data issue that we had was overruled by the advent of machine learning, where intelligence is drawn from data. And thank God we have several huge data sets. And so big data is no longer the problem, but how to draw intelligence from the data is now the problem. And that's why machine learning plays a key role in today's representation as well. And so to adapt new circumstances, we try to detect and extrapolate patterns from existing data. Such an area like natural language processing also set in to communicate with the machines as well. And we try to represent knowledge because we know we need to knowledge. There is need to support models of problem solving and expose this constraint as showcased in that definition of artificial intelligence I earlier showcased. And so we know that from there, from this constraint, we will be able to yield new knowledge. We will have more power. We will have more speed to reason with zero or small data. And so today's ongoing research is actually focused on improving efficiency and accuracy of knowledge representation methods, particularly in the context of big data and machine learning. And so to learn anything today, you have to already know. So if we wish machines to learn, we should be able to represent the whatsoever knowledge we acquire or we feel the machine should learn from. We should be able to structurally represent them. And that's why I say to learn, you already know. And to represent, we settle on several formalisms. Today, we've seen that the semantic web is gaining waves. And so we try as much as possible to adapt the formalism that help us to represent any knowledge that we have or we want to showcase. We want to represent it on the semantic web. And so apart from the classical logical formalisms, we also know that there are graphical representations. We don't think of probabilistic approaches because it's not appropriate here on the web. So we move to graphical. And under graphical representations, we have the RDF graph representations, and we today have the most suitable for semantic web, which is the ontologies and knowledge graph. And so towards a semantic knowledge ecosystem, there are different users and storage media, but we can have same schema, which is what the ontologies provide for us. Every other thing can be based on that same ontological schema, and other knowledge will be adapted from there. And so when we are talking about ontologies, we talk about formal representations, where the logical languages are adapted, accurately codify and reason about the world. This can be done explicitly, sharing the conceptualizations of certain domains as we may deem it fit. And we also will try to make it, when we say formal, it means we have to represent it in such a way that the machines will understand it, because machine understandability is a key role as much as we want machines to represent humans. And so knowledge representation and semantic web today are intermarrying, because it cannot stay alone. We will represent, whom are you representing for? Semantic web is what makes machines to want to learn or want to get from the knowledge that is in existence. And so we try to look at concepts from knowledge representation reasoning with markup languages based on XML as integral part of semantic web. We also look at the additional semantics that are added by the web ontology language and integrate the classification reasoner as much as possible. Let me take us a bit back to what we've probably commonly seen over literatures. And we have what we call the semantic web layer. And here we also have the area that is interesting, which is certainly on what I've just talked about. Talking about formalization, we have made mention of the ontologies and the web languages, and then the logic. Today we settle on the proof and the trust of the whatsoever innovations we are trying to create. And so that's the area in which knowledge representation will have to play a very vital role today in order to help us to gain the trust and to gain the proof of any system we are trying to build. We've heard of ontologies as what provides the schema, the generic schema for whatsoever innovations we have in mind. And so the goal of ontologies is to provide semantic knowledge ecosystem. Ontologies will help us to provide semantic data, which is going to be reusable, workable anywhere. Interoperability is the key thing that Ontologies has helped to grant to most innovative ideas that we are building today on the web. So these ontologies follow a simple strategy, which is a structure called the triple data structure. We're used to it. And then it helps to transfer data into triple store or graph database. Ontologies are really, really required where there is need for heterogeneous data, there is need for more than one system or the other. And so we can achieve what we want if we have any tool, but we base it on the same schema. And so we have several types of ontologies depending on the problem we're looking at, be it upper or domain or task and application ontologies. We also have different languages depending on what we are familiar with or what we want to use and the environment we want to use it. So like we have the informal language, the semi-formal and the formal language. We have just talked about ontologies following the triple store structure. That's the formal structure. And the structure of the ontology is guided and defined by axioms. So we provide logical axioms, which will provide an unbiased view on reality. So modelers of domain or application-specific ontologies may find it useful to avoid possibly erroneous ontological assumptions in modeling large-scale ontologies. And so the maintenance of independent view on reality yields following properties. Firstly, we talk of indefinite expandability, where consistency of content is maintained. Talk about content and context independence. We talk about different levels of granularity are being accommodated. So ontologies on their own follow this triple store and focuses on nature of reasoning rather than nature of real world. And it makes the common sense reality and natural language to be focal, very focal and seen. It is beneficial to knowledge construction processes in yielding high value knowledge bases. And so when we talk about formal, we mean converting to logic. So whatever we are doing, like the subject verb object structure of natural languages, we've seen that it follows a particular logical pattern. So we have the concept, we have the symbol that stands for a particular object. The concept refers to a particular object. And then we have the sets or the logical languages, depending on the language of construct in use, which of course is symbolic in nature. And so building a domain knowledge will first help us to define the conceptualization. That means an abstract model of phenomenon of the world. So when you're talking about any concept which you're trying to model or bring into your innovative or innovation, you have to first of all define it. And then the explicit nature of that concept, the type of concept used and the constraint on their usage, because everything in life is built on constraint, like I said. And then we also talk about formal in nature. When we say formal in nature, it means machines can be able to read them. So making them machine readable. And mostly what ontologies stand for is the shareability, the ability for that consensual knowledge to be shared, irrespective of platforms. And so an ontology defines the basic terms and relations as we may have a topic area as well as the rules for combining the terms and their relations. So we also have seen that formal ontologies and representation will not rule away formal axioms. So model sentences that are always true are also incorporated into our representations. So we represent knowledge that cannot be formally defined by the other component into the formal axioms. And then a successful formal ontology must accurately represent the most common information point of interest to a particular domain and the relationships that users want to trace between entities, creating the information structures which allow representation, not just to highly accurate information, but also more general and uncertain information. So ontologies play that role, and we have today several languages. We have several languages that run ontologies. We have several tools, because after we've run, we also have to check for consistency. We have to check for whatever we are doing, and then we need to evaluate. Thank God today, most of the evaluation tools are integrated into most of the ontology platforms or templates that we have. And so formal ontology and knowledge representation, as I made mention of the subject, verb, object statement, is a formal structure, a logical structure that will help to form a graph of classes and relations. Formats based around these logical forms include most popular RDF and the O language, which I've earlier made mention of. And so this triple store is actually the technical term for the subject-verb object relation. And the next thing we do in representation, after we've done these structures, we try to link all of them together in unlimited chains of information to help in reasoning, so that reasoning will be made possible. And then roles of formal ontologies, I have made mention of some of them, include creating novel specific domain ontologies, cross-mapping taxonomies, databases, and non-formal ontologies, empowering natural language processing, and then normalizing some of this, the databases and instant data that we have, creating knowledge bases, systems that have some domain of interest. And so these are some of the things that the formal ontologies will help us to achieve. And the key features means the contextual model that will be created will improve the classification part of what we've been having before now. So reasoning and knowledge will be working hand in hand. New knowledge will be formed when proper reasoning have been made possible through an effective representation pathway. And so the representation of real domains of knowledge in context of the semantic web may encounter difficulties if only classical logical formalisms are used as underlying. And that's where ontologies seem to be the underlying framework in today's semantic web. We also have, this is not the case in probabilistic nature of knowledge, of course. We also know that inductive reasoning in knowledge graphs are following the underlying ontologies for anything that is done there. And then various kinds of uncertainties in knowledge graphs are able to be handled as several plugins today. Uncertainties are overcome by some of the fuzzy plugins we have today to play with the ontology. So we have several plugins that can help us to handle the uncertainties or the complexities of the domain knowledge that have been represented, well represented. We talk about proper representation. And so you see that knowledge graph today as used by the key repositories, we know that they are just formal representations as used by key repositories like Wikipedia, Freebase, Wiki, and Wikipedia are also being based on these ontologies as the underlying schemas. So formal representation semantics are made possible to enhance the reasoning capabilities of any innovative ideas, and any innovation that we want to do is must be based on what will be made available on the semantic web. So that's, I think, the bits that I wanted to talk about. So to wrap up, I would love to showcase some of the few things that we do in formal ontological reasoning and representation of knowledge lab in my university, which I founded. This is made up of faculty members of my department and other collaborating institutions around here, and even other collaborators like the Short Guru Lab in India. We collaborate with them. And it's not a standalone because it's still within the university. So several researchers in the lab have cut across. Some of these ones have highlighted the spatial qualification logic timetabling project. We've done the preposition enable parser, call it PNLP parser. We have the proposition enable spatial ontology, which has been launched, and we have the personal profile ontology. Current work is on towards incorporating multilingualism and making it a multilingual semantic web, whatever we are building. And so we've been using the freeform tools in Protege, and that's what we've been working on, and the languages that we've been adopting there. And we start to first order logic, description logic, semantic web rule language as adopted in the W3C. So I think time may not permit me to talk about some of the deliverables that we have. We've been able to model these ones, and they are available. We also, this is a structure which is not showing. Why was it not showing? Okay. That was a spatial qualification logic model diagram. And this shows some of the reasoning, some of the relations that we had in that model. And we had the interval-based temporal ontology, which is the model diagram is shown here. We also have the PNLP parser, which was launched in the 2021. We also have the updated version of that parser is on the way. is yet to be uploaded. And so we have the hosting of that previous one is not currently due to cost. We didn't allow it to run. And then we have the maternal neonatal child health data set, which is available. We could see the F1000 publication and the link on how to get the data set based on that project. And then we have the preposition enable spatial ontology. This is the framework for it, which are some of the projects that our lab undertook. And this is the evaluation screen of the project. There's the link to that project. The updated version is what I said we'll have. Some of the literatures, as you could find them in my Google Scholar, some of them are listed here from this project. You could, for detail, whatsoever we've done, you could read up in those articles. So before I end, permit me to still acknowledge few persons. The Tertiary Education Trust Fund, Nigeria, because their grant, institution-based grant, has helped to support these researches. Some of these researches, I say thank you to my University of Uyo, Nigeria, for granting us the enabling environment which we run for the research space. Thank you to Folk Lab. When I'm talking about Folk Lab, I mean the manpower and the research ideas, where the research ideas actually come up from. Thanks to TIB Lab at Germany for the 2-time grants they've given unto us, because even some of our current projects are emanating from works that they grant from Germany. Help us. Thank you for the Short Guru Lab, our research partner, for some of the links we get today is as a result of them. So in conclusion, I want to say that knowledge representation is seen as the most important ingredient for developing an AI system, any AI system that we may think of. It's a layer between information accessible from outside the world and high-level thinking processes. The thinking processes in AI are identified by knowledge representation. So the specific domain knowledge is required for presentation and reasoning. And so hence, we see knowledge representation as the bedrock of artificial intelligence. And in principle, since today's innovation is formed around artificial intelligence, it then means by extension that knowledge representation is the bedrock of today's innovation. And that's where I'll draw the curtain. Some of our references are here. And if we want to ask any further questions or collaborations, my emails are showcased here. And so I wish that you contact me or the organizers of this wonderful program. Thank you very much for your time and your audience. Thank you. Oh, yeah. Already we have questions. As students, we don't have much background in this idea. Could you please explain in very simple terms what an ontology is and how it is useful in everyday life? Okay, if I could quickly take that, permit me to run down it. And in long run, what can we contribute to? And since we are just starting to learn, what will be the best way for students to start off in this field? Okay, let me quickly take the simple one. Ontology, an ontology. The term ontology is a philosophical terminology Philosophers first used the word ontology to mean existence of beings. And computer science and computer scientists adopted the word, the term in computation, because we see that to model anything in life, and life in itself is through abstraction. You cannot just model the whole world as it is. And so for you to model any part of the world, you first know of that, the existence of that part of the world to be in existence before you think of modeling. And so that makes computer scientists to borrow that key term. And so today, an ontology is actually a conceptualization of any domain knowledge. What do I mean by conceptualization? You look at an object in the world. What are the key objects that play around that particular object in the world? After you have said that, you have known that these are the key entities that make up that concept in the world. The next thing you need is, how do these entities relate to each other? So when you now know of the relationships, the various relationships among the various entities, it means you're forming a conceptualization of the various concepts or the various entities and the relationships around that particular domain or around that world. And so that's what we keep doing in life. Concepts in life are put forward in abstractions. And then computer science have adopted ontology as the underlying schema or the framework of which knowledge are put forward on the semantic web. Since mostly what we model or innovations that we do today are taken to the semantic web for onward interoperation on all platforms or anywhere on the semantic web. In the long run, we see that everything, if I model a particular concept in Nigeria, you model one from India, another person models one from any part of the world. In a long run, we would have been able to model eventually everything in the world in patches. And then the good thing is that there is room for these different knowledge that are put forward at different times to be linked up together. And so in the long run, every concept in the world must have been linked together so that what is the situation in India can be married to what is the situation in Nigeria, and then we can generalize and say this is a situation about this particular concept. And so since you are just starting to learn, yes, we have a lot of resources. So if you contact me, I could share with you some of the resources that you could start from and learn as far as this field is concerned. I think that's what I will have to say there. I don't know if there is any other. Okay. And there is no. Okay.
You are
Thank
now
you.
unmuted.
Thank you.
Okay, so we had a very wonderful session right now. Let us move on to our second keynote of the day. Let us move on to our second keynote delivered by Ms. Vidushi Bhardwaj, a passionate design leader with over 3 years of experience in user experience and product design. Today, she will give us a session on human centered design in engineering practice. To tell more about her, she's an alumna of NIFT Delhi and IIT Hyderabad with certification in human computer interaction from IIT Bombay. She currently serves as an UI UX designer and business associate at Talendy Holdings. Alongside her industry work, she mentors emerging designers, encouraging design practices built on empathy and intentionality. She's also empaneled with Ministry of Textiles, Government of India as a designer for handicrafts and recently served as a jury member for the Shilp Guru and National Handicrafts Awards, India's highest honor in the craft sector. Ma'am, over to you.
Thank you so much, Ishrat. Thank you so much
You
for
are
the
now
kind
muted.
introduction. Please let me upload my presentation.
You are now unmuted.
Is there an option by which I can share my screen? Oh, okay, got it.
You are now muted.
I hope my screen is visible to everyone.
You are now unmuted.
Okay.
You are now muted.
All right. Thank you, everyone. Thank you for the kind introduction, Ishrat. I'm very obliged to be here with you all today. So now that you've already given my introduction, I will start with my presentation. So a quick show of hands, since we are doing this on virtual mode. Actually, you can quickly drop in the chat also and say hi. So I want to ask all of you, how many of you have yelled at a computer, a phone, or an Alexa in the past week? Be honest. Do we have the chat enabled?
You are now unmuted.
Okay. Sure. I see a few messages. Okay. So, congratulations. Great news. You already qualify
You
as
are now
people
muted.
who deeply interact with technology. And this is what today's whole session is going to be about. It's about human computer interaction, or what we call as HCI. Don't worry, I'll try to keep this very light, funny, and practical. No boring lecture, no jargons. My goal here is extremely simple. By the end of this hour, I want you to understand why HCI is not just for designers, for engineers, or computer scientists. It's for every innovator, every human being who builds technology and must deeply care about it. Okay, so moving on to the next slide. Every single day, whether we realize it or not, we are always in a constant dialogue with machines. From the moment our alarms wake up to the moment we set a reminder before going to sleep, or the moment when we send a message on WhatsApp to a friend. Technology is seamlessly woven into our lives. Today, we'll explore how human computer interaction, the field that studies this exact dialogue, is so important. And we'll also see how it's shaping the future of technology. Let me ask you a quick question. How many times did you interact with technology breakfast today? Take a moment, think about it. Did you check WhatsApp or Instagram today? Maybe you even used Google Maps to navigate through traffic. Or did you even stand by a coffee machine that works on a function or a program? These are small but very powerful examples of HCI in action. We often take them for granted because they are so seamlessly integrated in our lives. But each of these moments is a design decision that makes this interaction possible. In fact, some of you would probably hit snooze on your alarm 3 times. I know, I do that. Because the designers realize that humans aren't machines that will wake up at the very first beep. So, moving on to why HCI matters in the first place. It is because HCI is not just about designing a great looking app or a pretty interface. It's about creating a conversation between humans and technology that feels very natural. Think about it. An app that looks good but is extremely confusing to use, or a machine that is very powerful but inaccessible to most people. Both fail terribly. So, HCI is not about just usability, accessibility, emotions, but it is also about safety. It ensures that technology adapts to humans and it's never the other way around. I'm sure you must have always heard your parents or your grandparents say this sometimes. This app is too complicated. I don't like it. It's not their fault. That's just bad HCI. A well designed system should feel natural no matter who's using it, whether it's a tech savvy student or your grandmother trying to order groceries online. So here's the big question: how can technology truly understand humans? In today's world, we've built incredibly advanced systems, from computers to AI models to robots. But unless they're designed with humans in mind, they end up frustrating us instead of helping us. So, the challenge of HCI here is to bridge this gap, making technology not just functional, but intuitive, empathetic, and most importantly, human centered. Now, think about your favorite app. Do you like it? It's probably because it feels easy, it feels fast, it's very pleasant to use, maybe even meditative at some times. Now think about your least favorite government website. I know I have a few. Yes, the ones which make you upload a 200 KB photograph, 5 by 5 centimeter on a white background only. And after you upload the file, it still says the file is invalid without giving you a proper explanation for it. That's the absence of HCI. The technology exists, but the humans are suffering utterly. So, what exactly is HCI? I'm sure that by now you must have understood that we are talking about this dialogue and this conversation between humans and computers. But let me give you the textbook definition of HCI, and this is the only textbookish thing that I'll talk about today. So it is basically nothing but the study and design of how people interact with computers. But you really need to notice the second part here: how computers can better serve people. That is the real essence. HCI is both a science rooted in psychology, ergonomics, and research, and an art combining design, engineering, and creativity. It sits right at the intersection of human needs and technological possibilities. Think of it like this. For example, engineering builds the engine, but the HCI designs the steering wheel, the dashboard, and even the seat belt. Without HCI, you might have a Ferrari engine with a bicycle handle to it. Does that sound very safe or useful? No, right? Now let's move on to a very everyday example. I'm sure you must have all made Maggie in some point of your lives. It's the easiest thing to make out there. So let us suppose that we are writing an algorithm for making Maggie. So what would the step one be? It would be to boil the water. But what if there is no gas? It's an edge case, right? Step two, what would that be? We need to add the noodles. But how much water do we add exactly? There's a lot of ambiguity there. And then the step three would be to add the taste maker. But do we have to add that before boiling or after boiling? What is the sequence here? Even here, we have hit constraints like inputs, errors, timing, state changes, etc. That's engineering. Now, what would HCI do here? It would add clear instructions, defaults, a timer, and maybe even a warning caution saying hot, don't touch. This is why Maggie takes longer than 2 minutes, guys. It's not a cooking problem, it's an HCI problem. And honestly, Maggie is one of the first HCI training many of us have had as kids, where we were learning edge cases even before we knew it. Now let's move on to another example. Again, a very everyday example, doors. Have you ever pulled a door that's supposed to be pushed or even walked through a door that is made of transparent glass? I'm sure most of you have. You feel so silly in that moment, right? But it's not your fault, it's just bad design. By the way, these doors are called Norman doors because there's a specific term for these confusing doors. And why this happens is because the handle affords pulling, but the sign says push. So basically, there's a conflict. And this is classic HCI. Machines don't make people clumsy, bad design does. And if our interfaces fight the human intuition, the humans lose, and so do our products in the long term. Think of it. If opening a door is hard, imagine what it means when you're designing an app that controls money, health, or safety for that matter. Now let us move to something very basic in HCI, and but these are two extremely powerful concepts. They are called affordances and signifiers. So an affordance is basically what an object allows you to do. For example, when you see a chair, what do you think? You immediately know that you can go and sit on it. That's affordance. A button on a screen that affords pressing, a handle on a door that affords pulling. So these are all natural actions an object invites without even needing to explain it to you. But then there's a slight twist. Sometimes affordances aren't enough. That's where signifiers come in. A signifier is nothing but it's a clue that tells you how to use something. Think of a door with a flat plate that says push. The plate affords pushing, and the label is the signifier. Or on your phone, there's a little trash can that most of us use. It doesn't physically afford anything, but it signifies that, hey, click here if you want to delete something. Now, here's the fun part. When affordances and signifiers don't match, that's where the chaos and the conflict begins. Ever pulled a door hard with a handle only to notice a tiny sticker at the side saying push? That's called a Norman door, something that we discussed earlier, right? So the result is that people look silly, and this is the fault in the design, not in the person. So, in short, affordance is what you can do, signifier hints telling you how you should do it. And when they work well together, design feels effortless. But when they fight with each other, you end up standing outside the door looking confused while everyone else stares at you. Now, let's dive a bit into the history of HCI. I'll try to keep it very short because history is not something most of us enjoy, right? But it's also very extremely important to know that how HCI came into action, how was the term coined, and why we are talking about it today. So back in the days in 1950s and 1960s, computers weren't really designed for everyday people at all. In fact, early computers only spoke in binary codes and punch cards. If you weren't a scientist or a mathematician, you couldn't even talk to them. Computers were for machines, they were not for humans. In fact, they were massive machines operated through cards and command lines. Now imagine you have to type a long cryptic command just to do a simple task. I mean, you guys are all engineers, you might do that, but trust me, that's not my cup of tea. So these systems were extremely intimidating, they were inaccessible, and only experts or scientists could use them. Technology wasn't built for humans yet. Imagine you want to say hello world today. You can do it in seconds with a programming language, but back then you had to punch holes in card and feed them to a machine the size of a room. If you dropped one card, the game was over. Now let's fast forward to 1970s. And this is when the researchers at Xerox PARC dreamed of something magical, something that had never been done before. And they had introduced icons, windows, and the mouse. So what you see on the right is the very first mouse that was developed by Xerox PARC. And suddenly, instead of typing commands and using punch cards, you could just point and click. And that was extremely revolutionary. Then came the 1980s. That is when the term human computer interaction was officially coined and the rise of graphical user interfaces also came in. And in 1984, we all know that Apple launched the Macintosh. For the very first time in history, ordinary people could point, click, and navigate without memorizing the commands. Computing became personal, approachable, and even enjoyable. Like Steve Jobs famously said, people don't know what they want until you show it to them. And Mac showed the world exactly what human centered design could look like. At the very same time, computers were also entering critical domains like aviation, healthcare, banking, and military. Imagine here a small design flaw wasn't just annoying, it could be catastrophic. An unclear screen or a badly designed control could cost lives. That's when HCI evolved more into something more than convenience. It became something about safety and reliability. And then also came the translation problem. Because humans think in languages, images, and symbols, right? Computers understand only numbers and logic gates. There had to be a bridge, a way to translate the human mental models into the machine logic, and that gap had to be bridged. That bridge eventually became HCI. Now, this was a huge shift in thinking. Instead of forcing humans to adapt to computers, the new philosophy was design computers that adapt to humans. That's human centered design. And honestly, thank goodness they did. Otherwise, we'll all still be carrying those punch cards even to class today. And then the rest is history. The mouses and the graphical user interfaces came, then came the touch screens, the voice assistants, AR, VR, and then it's been a journey of milestones. The mouse and the GUI changed everything forever. Touchscreens made technology more direct and tactile. Think of how natural it feels to swipe on your phone. Then also came the voice assistants that we use today, like Siri, Alexa, Google Assistant, which allow us to use most natural form of communication, our own speech. And today we are exploring immersive worlds through augmented and virtual reality. Each of these breakthroughs expanded not just what technology could do, but also who could use it and how easily. Remember the first time you zoomed onto a photo of yours with two fingers? Didn't it feel like pure magic? Or when you asked Alexa to play the music, but she misunderstood, and suddenly your playlist went from Arijit Singh to maybe heavy metal? But that's also HCI, right? It's a HCI in progress, but still we are reaching there. Now, moving on to the pillars of HCI. This is something which is utmost important because this is the foundation on which any good interaction between human and computer sits. So I will be talking about these one by one. I'll try to keep it short and I will also try to explain it to you how each of these pillars are important with examples. So the first pillar, which is the usability. So at its heart, usability is nothing but it's about making technology usable. Can people figure out what I'm trying to convey quickly? Can they achieve their goals without any frustration? So if your grandmother can transfer money using UPI with just a few taps, that's usability in action. If I give you a real life example, you can think about Google Pay and Phone Pay, how they have made payments so simple. Even the first time users with little technical know how can complete a transaction in under a minute. Moving on to the second pillar of HCI, which is accessibility. Technology should work for everyone, including people with special abilities. Inclusivity in HCI means designing for everyone, not just for an average user. If your product works only for some, then honestly, it doesn't work at all. And inclusive design is not only more ethical, it's also more successful because a product that embraces diversity will always reach further and last longer. For example, screen readers, captions on videos, voice inputs for those who cannot type. These are all examples of making the systems inclusive. Accessibility is not a charity, it is good engineering and something that each one of us here should imbibe. Moving on to the third pillar, which is user experience and emotions. So, in this, how does it feel when you use a particular system? Does it feel frustrating, pleasant, addictive? These design choices create emotions, and emotions influence adoption. Think of how satisfying it is when you hear that ding after sending money successfully on Google Pay. It's a tiny burst of joy, right? But it's designed into the system. Let me give you a real life example. I don't know how many of you have used Duolingo, but it's an app that makes learning languages very easy. It gamifies things, it has animations, it gives you streaks and rewards, and this makes the whole pleasant experience very pleasant and an addictive habit. Moving on to the fourth pillar, which is efficiency and performance. HCI is also about speed. How many steps does it take for you to get something done? Engineers build powerful systems, but HCI ensures that you don't need 15 clicks to do something that can be done in 2 clicks. For example, if you've ever ordered food on Swiggy and Zomato, you must have seen in their interface that they always have your past orders and addresses. That is there to make sure that reordering food is easy and a one click job for you instead of filling the forms all over again. Moving on to the next one, which is safety and error prevention. In critical systems like aviation or healthcare, a poor interface can be disastrous. So, HCI focuses on preventing errors, providing clear warnings, and making systems robust against mistakes. Even in everyday apps, you have the undo buttons and confirmations that are safety nets. For example, if you've ever typed a message or an email on Gmail, you know that there's an unsend button that you have. So that is there to save you from embarrassing typos or from sending the email to the wrong recipient. And lastly, but also amongst the very important pillars of HCI is the cultural and contextual fit. HCI also recognizes that culture shapes how we use technology. For example, in Japan, people prefer silent payment confirmations on trains, but in India, we love the loud payment received sound at chai stalls, don't we? So, HCI should respect context also. We need to understand whom we are designing for, and we have to design keeping that in mind. Now, moving on to HCI, which is everywhere shaping our world, and let us bring it down to our everyday lives. Sometimes people think that HCI is just an abstract academic concept locked up in labs, but trust me, that's not the case. The truth is, you've already used it at least 5 to 10 times today without even noticing it. For example, take Netflix recommendations. When you go to home from college or when you go to home from work, a long day of work, and magically Netflix seems to know everything that you're in mood of, whether it's a rom-com or it's a thriller. That's actually HCI at work, designing a recommendation interface that feels personal and intuitive. Of course, sometimes it can hilariously misfire. It has a lot of times. There was one time I started watching documentary on sharks, and suddenly Netflix assumed that I'm training to be a marine biologist. But that again, it's HCI. It's learning, it's adapting, and it's presenting the way that a human feels. Now let's also talk about Google Maps. Imagine life without it. I cannot imagine a life without it. Google Maps doesn't just calculate routes, it talks to us with voice, visuals, giving just the right level of detail so that we don't crash while trying to read that tiny text. It's a perfect example of multimodal HCI. Visuals for planning, audio for on the go execution. Without it, we would all literally be lost today. In fact, something as ordinary as withdrawing money from ATM. That's again a fascinating HCI story. The interface has to be so clear and so universal that everyone, whether they are young or old, tech savvy or not, can walk up, insert a card, and get the cash without any anxiety. Have you ever stood behind somebody who took 10 minutes to take out cash from the ATM? If you have, then you know why a good interface matters. And finally, coming to smart homes today, voice assistants like Alexa, Google Home, they're redefining how we interact with our environments. You no longer press buttons, you just speak. And this shows how close we are to making human computer interaction feel like a conversation. Now, let me give you a real story of a very good HCI example in everyday life. Think of the UPI payments in India. Back when the demonetization happened, UPI didn't just digitize payments, it domesticated them. The interface was so simple that everyone, from college students to chai stall vendors, could use it. You could just scan, tap in a pin, and you're done. It worked so well because there was low friction, clear feedback, and trust cues. That little sound of payment confirmation, that was not just audio, it was a joy by design. So in this case, HCI turned something as complex as digital banking into a universal habit that majority of us use today. Now let's zoom into the world of engineering that you all are aware of, where HCI is not just about convenience, it's about reliability and it's about safety. Picture an industrial control panel in a power plant. One poorly placed button, one confusing label, and you could have the disaster in your hands. Engineers working in these environments don't have the luxury of trial and error. The interface must guide them towards the right actions, especially even if they're under pressure. Or consider dashboards and monitoring tools in factories. These systems handle vast and complex amounts of data. The challenge here is that we have to present that data in such a format that humans can make sense of it at one glance. If the operator has to squint and puzzle over the graphs for 10 minutes, it really defeats the purpose. Good HCI here means clarity, it means prioritization, and it means the right use of colors and alerts. And in medical devices, the stakes go even higher. Every design decision can mean the difference between success and failure in treatment. Imagine a surgeon navigating a cluttered, confusing device interface using a procedure that's unacceptable. HCI in engineering is what turns raw power into safe, dependable performance. In other words, without good design, even the most advanced machines are just expensive liability. But what happens when HCI is ignored? Now, let me give you a bad example of it or a cautionary tale. I would like to tell you about the Lascat disaster that happened in London in 1992. So, there was this ambulance service that was newly launched and it was rolled out. And they had a brand new computer dispatch system. And they were hoping to speed things up. But instead, because of the poor interface design, unintuitive screens, and very confusing alerts, there were no safety checks. Calls started being lost, ambulances went to the wrong places, and in some cases, the help arrived several hours later. In fact, the media also speculated that dozens of lives may have been lost. Now, that wasn't a technical bug, it was a complete HCI failure. In high stakes engineering systems, design isn't just decoration, it's about life or death. Now, let's move into something very close to all of our hearts: education. I hope you all remember the pandemic years, right? When suddenly we were all sitting at home in lockdown and wondering what to do. But, thanks to HCI and thanks to the companies that made everything digital. So we had Zoom, we had Google Classroom, Coursera, Khan Academy, everyone became virtual teachers overnight. And what we are doing today here is exactly a result of that. Here's the thing: if those platforms had been clunky or confusing, the entire experiment of online education would have collapsed. Students would have disengaged, teachers probably would have given up, and parents would have surely gone on a strike. But instead, thoughtful HCI design made it possible for millions to keep learning. When the interface is simple, interactive, and rewarding, learning becomes very engaging. Gamified quizzes, breakout rooms, and even the digital whiteboards that we all used, these are all examples of HCI principles making education more human even through a screen. Now think about it in terms of inclusivity. Imagine a child with hearing difficulties. The caption in Zoom became their lifeline. Now imagine a student in a rural setting who's trying to access Coursera in a low bandwidth connection. The lightweight, mobile friendly design kept them included. This is the power of HCI. It's not just shaping how we learn, but also who gets to learn. Now let's enter the world of healthcare, given how advanced it has become today, where usability is literally a matter of life and death. Take the MRI machine, for example. Doesn't it look intimidating? But for a technician, the interface must be crystal clear. What settings to use, what sequence to run. There's a zero room for error. A poorly designed interface here isn't just frustrating, it's extremely dangerous. Or consider robotic surgeries like the Da Vinci surgical system. These machines allow surgeons to perform incredibly delicate procedures with robotic precision. But the only reason this works is because the controls are designed to be intuitive. If the surgeon had to fumble through those chunky menus where while operating where he does not understand a thing, we'd all be in very serious trouble. So here HCI ensures both patient safety as well as the medical effectiveness. So good design can literally save lives. And when we think about it, HCI in healthcare is one of the clearest proofs that it's not just about convenience, this is about survival. And finally, let's talk about transportation, one of my favorite topics, where millions of us depend on a well designed interface. Have you ever looked at an airplane cockpit? Do you know it is one of the most complex HCI environments in the world with hundreds of buttons, dials, displays, and yet everything is placed and grouped so carefully that pilots can make rapid, accurate decisions even under extreme stress situations. A single misleading light or a poorly placed control can have devastating consequences here. Let's also take the example of Tesla's autopilot interface. Here, trust is such a big challenge. The driver must trust the system enough to use it, but not so much that they can become complacent. A poorly designed interface could cause drivers to overtrust or undertrust the system. And trust me, both of these situations are equally dangerous. A good HCI is about balance, giving humans confidence without giving them the false sense of security. And here's the fun part. Many of you have probably interacted with at least three or four of the systems that I've mentioned today already. Netflix, Google Maps, or maybe even used an ATM or smart assistant today. That's the power of HCI. It's not something you always notice, but it's everywhere. It's ubiquitous and it's omnipresent. It's quietly shaping your safety, your comfort, and even your happiness. So let me leave you with this thought. Human computer interaction is everywhere, and sometimes it feels extremely invisible. That's the silent magic of good design. It works so well that you barely notice it. But on the other end of the spectrum, we have disasters like the London ambulance service that we recently talked about. Poorly designed systems meant calls got logged, ambulances didn't arrive on time, and so many lives were lost. Here, a bad design wasn't just annoying, it was catastrophic. And in the middle, we have high tech systems like Tesla's autopilot. They show us the delicate balance of trust, how much to rely on machines and how much to stay in control of our own selves. So, whether it's your evening Netflix binge or your daily UPI transaction or a pilot landing on the runway, the lesson is the same. Good HCI quietly empowers us, but bad HCI can fail us loudly and dangerously. So the next time you get frustrated on an app or cheer when a task feels extremely effortless, remember you are experiencing the hidden hand of design. And as engineers, you are the one who can decide whether people end up getting lost, empowered, or saved. That's a power as well as a responsibility. Now let us do a quick fun exercise. Okay, so you see two remotes here on the screen. There's remote A and there's remote B. And I want you all to take a minute and decide which one looks like a better design to you. So I'll give you 30 seconds. You can quickly maybe put your answers on the chat. And if there's voice enabled, then maybe some of you can even speak. I'll take a quick water break till then. But by the end of the 30 seconds, I want to know your answers. I hardly see messages on the public chat. Which one do you think is a better design, remote A or remote B?
You are now unmuted.
The remote A. Okay.
You are now
How
muted.
many of you second that? Okay. All right. Yeah, that's correct. Remote A is a better design because it's sleek and it's minimal and it's almost meditative if you look at it. It's just a handful of buttons, nothing too much, nothing too less, and it has all the essentials placed very systematically. I think if you hand this over to your grandmother, even she'll be able to figure it out in seconds. In fact, this remote is so simple that you might even start wondering if you're actually smart. But now you look at remote P. How does that look to you? Doesn't it look so complicated? To me, it almost looks like a cockpit of Boeing 747. I don't understand if I look at it. If I press the wrong button, I'm going to change the channel or launch a satellite accidentally. So that's the feeling a good design or a bad design can give you. Now the remote A is better because it firstly it has simplicity. It only gives you what you need. Secondly, the ease of use. You don't need a manual or you don't need an engineering degree to figure out what it says or what it does. Thirdly, accessibility, bigger, fewer buttons without even giving too much of explanation. And fourthly, it also follows a very minimalist modern standards of design. Now let's look at another example. Okay, so here you have interface A and you have interface B. Which one looks better to you? Come on, take a wild guess. Is it interface A or is it interface B? Okay, I see somebody's answer. They are saying interface B. Yes, you're absolutely correct. Interface B is the correct one because if you look at interface A, it gives you a very mysterious message saying error, and that's it. There's no explanation, there's no guidance. It's just pure judgment. It almost feels like the system is saying, you messed up, now you figure it out. But if you look at the interface B on the right, which is the correct answer, this one is a lot more empathetic. It's kinder. It tells you that the password is incorrect, but it also tells you that you can reset it and how you can move further from this problem. It basically says that, this is the wrong answer, but here's how you can get it right. So, why interface B is better? Because, firstly, it offers clarity. It tells the user exactly what went wrong. It gives you actionable feedback. So, it basically tells you the steps that you need to do. And then accessibility, the error is clearly highlighted with both text as well as visuals. And lastly, user empathy. It reduces frustration, and it's also showing you a kind message by telling you where you went wrong. So I hope you enjoyed this activity. This is something that all of us should do. Now, I this is one thing I you as engineering students should do. Whenever you look at a design or an app or an interface, I want you to look at it from a very critical point of view. I want you to try to decode if it is a bad design or it is a good design. This is something which will help you sensitize your eyes towards HCI, and in the longer run, it will be very beneficial. Now, moving on to AI and adaptive systems. So, now we are entering a world where interfaces are no longer static. In fact, in the past few years, um, the websites or applications almost look like a notice board. You put up some information and people came, they read it. But if you look today, interfaces are becoming more like living companions. They learn from us, they adapt to us, and sometimes they even anticipate what we need even before we ask. Think about Netflix. Doesn't it show you? It doesn't show you a random list of movies, right? It learns from what you watch, how long you watch it, when you pause, and even if you abandon some content after 10 minutes, it still uses that knowledge to predict your next binge. You can also look at Gmail's Smart Compose. Once you start typing, it almost finishes the sentences, like serendipity. For many of us, Gmail has practically become a writing partner. But the scary part is when it predicts your thoughts a little too well. These are all examples of adaptive user interface in action, systems that learn from us and respond in real time. This is exciting, very exciting, in fact, but it also raises tough questions. Do we design systems that are helpful without being creepy? At what point does personalization cross into manipulation? If an AI knows my habits better than I do, should it be allowed to nudge me? So, the challenge for future engineers and designers is not just building smart systems, but making sure those systems remain trustworthy, transparent, and respectful of the people who are using them. The future of HCI isn't about screens and keyboards anymore, it's about emotion. We've also stepped into a world where technology doesn't sit in front of us, it surrounds us completely. Think of AR and VR. These technologies are blending physical and digital spaces. Imagine being an architecture student and walking through your 3D design in a virtual reality before a single brick is laid. Or imagine shopping for online furniture. With AR, you don't have to guess whether the sofa is going to fit in my living room or not. You can literally place it there with your phone camera and see it for yourself. But it doesn't really stop there. Now we also have the brain computer interfaces, which are being developed that could allow people to control systems with their thoughts. This sounds like a science fiction movie, doesn't it? But early prototypes already exist. Imagine designing for that. No clicks, no taps, just intention translated into action. Of course, it also raises hilarious possibilities. Imagine thinking about pizza during a meeting, and suddenly your food app starts preparing an order. Clearly, design has to figure out where mind reading ends and where human dignity actually begins. And then we have the smart environments or the smart homes and offices that we are using every day. Even our cities are becoming smart interfaces themselves. Your house that adjusts the lighting and temperature automatically, your car that talks to traffic signals to find the fastest route. A city where streetlights dim when no one is around to save energy. In the future, we won't just use technology, we'll practically be living in it. So, the real question here becomes how do we design these immersive, invisible systems so that they feel empowering but not overwhelming? But here's the most important part. As exciting as all this sounds, AI, VR, AR, brain computer interfaces, smart cities, etc., none of it matters if the values behind design are wrong. Shawil Bhardwaj, a very well known HCI researcher, reminds us that HCI isn't just about usability and efficiency. Because let's be honest, what good is most efficient app if it violates our privacy, spreads bias, or excludes entire groups of people? So HCI must also include fairness, privacy, trust, and cultural relevance. Technology must not only work, it must work well for everyone. This means designing inclusive systems, for example, making sure facial recognition works equally well across different skin tones. It also means respecting privacy, not turning every data point into a monetization strategy, and it means designing with culture in mind. A payment sound that works in India might be a nuisance in Japan. A feature that motivates students in one culture might embarrass them in another. So, the future of HCI isn't just about smarter machines, it's about wiser design choices. Our job isn't just to build technology that adapts to humans, but technology that respects humans. So when you think about HCI of in the future, don't just imagine futuristic headsets or glowing dashboards. Imagine a world where technology is safe, fair, inclusive, respectful, delightful, and user centered. That's not good engineering, that's responsible engineering. Now, when we think of the future of HCI, one four stars above everything else. That's artificial intelligence, right? AI isn't just a new technology, it's changing rules of everything around us. It's changing the very rules of how humans and machines relate to each other. Traditionally, interfaces were like vending machines. You press a button and you get a result. The systems never really learned anything about you. But with AI, interfaces have memory, they have a personality, and they have adaptability. They don't just respond, they anticipate. Take voice assistants like Siri, Alexa, Google Assistant. Right now, they can set alarms and play music, but as they get smarter with time, they learn your habits. Imagine walking into a home after a long day. Your assistant already knows that you like dimmed lights, the AC at 24 degrees, and some soft music playing. That's AI turning interaction into intuition. Or consider adaptive UIs. AI will make interfaces flexible instead of one size fits all. For beginners, an app might show a simplified layout with a fewer buttons. For an expert, it could reveal more advanced features automatically. Imagine softwares that grow with you instead of forcing you to adapt to it. But here's where it gets tricky. AI's ability to predict and personalize also brings a lot of risks. If it knows too much, it starts to feel creepy. If it's trained on biased data, it can reinforce unfair stereotypes. Think about job platforms where algorithms suggest roles. If the system carries bias, it might hide opportunities from certain groups. That's not just bad design, that's a harmful design. So, the challenge of AI in HCI isn't just about making things smarter, it's about making them fair, transparent, and trustworthy. We need to design AI that explains itself. Imagine asking a system, why did you recommend this movie to me, or this product, or this medical treatment, and getting clear, human friendly answers. That's explainable AI, the next frontier of HCI. And let me tell you something very fascinating. AI will also blur the boundary of who adapts to whom. For decades, humans have adapted to machines. We learn their commands, their syntax, their quirks. But with AI, the roles reverse. Machines will increasingly adapt to humans, our language, our preferences, and our context. And that is a huge shift. And it puts big responsibility on us as engineers and designers. So, to sum it all, AI will make HCI more personalized, more adaptive, more natural, but only if we design it carefully. Otherwise, we risk creating systems that are manipulative, biased, or untrustworthy. The future of HCI with AI isn't just about smarter machines. It's about ensuring those machines are also kinder, fairer, and more human. Now that we have almost come to the end of this session, I want you to carry this one simple thought with you. HCI is not about machines, it's about people. I repeat, HCI is not about machines, it's about people. We often get dazzled by technology, faster processors, smarter algorithms, shinier gadgets. But at the heart of all this is a very human story. Technology exists to serve us, to extend our abilities, and to make our lives richer, safer, and more meaningful. The mouse, the touchscreen, the voice assistant, they are not just technical achievements. They are reminders that the most powerful innovations are the ones that understand human needs and naturally fit into our lives. If we ever forget this, if we focus only on the machine and not on the human, we will lose the very essence of HCI. So, what can we do? Now, I'll tell you a few best practices that you all must carry forward. Number one, keep it simple. Complexity belongs in the back end, not on the user screen. If somebody needs a manual to understand your product, then there's something terribly wrong with it. Secondly, always design for error. People will make mistakes. We are all humans. That's our nature. Your system should catch them, it should not punish them. Undo buttons, confirmations, and clear feedbacks are lifesavers. Thirdly, always think inclusively. Design for the widest range of users, different ages, languages, ability, cultures, races. Accessibility is not an afterthought, it's a core principle. And lastly, respect privacy and trust. Just because you can collect data doesn't mean you should. Design systems that are transparent and respectful of people's boundaries. Also, don't forget to test with real humans. Don't assume that you know how it works because you are not the user. Watch real people use your design. Even two users in a usability test will reveal a lot of things that you have never imagined. So here's my call to action for all of you, for every engineer, every designer, every policymaker, and really everybody today attending this conclave, is shaping how humans and technology will live together. That's a huge responsibility because the things that you design don't just sit on screens. They shape behavior, decisions, opportunities, and sometimes even lives. And above all, remember the human impact. A confusing interface might waste someone's time. A thoughtful one might save their day. A biased algorithm might shut doors. An inclusive one might open opportunities. As engineers and designers, our responsibility is not just to build systems that function, but it is to build systems that serve, systems that empower, not frustrate, systems that are safe, ethical, and respectful. Systems that remember that behind every click, tap, or command is a human being. So let's make that imprint thoughtful, let's make it inclusive, and let's make it human centered. Because the HCI future isn't about teaching humans to think like humans, think like machines. It's about ensuring machines understand and respect humans. And trust me, that's not just good design, it's good humanity. So, with this, we come to the end of our today's session. Thank you so much, everyone, for being such patient listeners and for having me here. If you would like to ask me questions, I'm here and I would love to answer your questions. You can also connect with me on LinkedIn. I've not put in my email here, but if you want to connect with me, I can also drop in my email on the chat.
You are now unmuted.
Okay. Sure, sure, definitely. Well, my advice would be that don't get very excited about what HCI can do. I think in the quest of making systems better and becoming more advanced, we are forgetting uh, the very human things that we should remember: privacy, respecting boundaries, trust. So I would just say that don't just be an engineer, be a social engineer. Don't just be a designer, be a social. So that would be my advice. Right. I think the most difficult one is for HCI to become intuitive. That's where majority of HCI fails. Speaking the user's language. That is not something
You are now muted.
uh, every person who knows HCI can do. It requires practice. It requires understanding systems and humans on a deeper level, and also mastering the dialogue and the conversation between them. So if you can make interfaces that are intuitive, that can speak the user's language, that can understand the human behavior, I think you would win at any task that you do.
You are now unmuted.
I think the most interesting part, okay, that's a good question. I
You
think
are
the
now
most
muted.
interesting part about HCI or designing in general is that it has to be contextual. There's something called as an ethnographic study. So what we do as designers is that firstly we assume that we are the ones who are going to be using the products. That's the very first mistake we do. We always have to remember that we are not the users and we are designing for a separate set of people, which means that we have to understand where they come from, what kinds of lives they are living, what their daily routine looks like. So basically, we have to live their lives for some time and we have to understand the cultural context. Like the example that I gave. So in Japan, uh, you can't click a picture without the shutter sound. Okay, so if you're clicking a picture, it's there on default on every smartphone that if you're clicking a picture, the shutter sound has to be there because it violates their privacy laws. But if you come to India, you have this option of silencing the shutter sound. So you have to understand the context of the place and the people that you're designing for. And I think this is one of the most interesting things when I design things. I love talking to people, I love taking their interviews, I love diving deep into their needs like a detective. And this has really helped me understand their pain points, their challenges, and how we can design better products that serve their needs.
You are now unmuted.
Sure, I can, but
You are now muted.
I mean, I can just tell you a bit brief of the projects that I've worked
You
on.
are
I
now
can't really pull
unmuted.
out the material and show you. But yes,
You are
I've
now
worked
muted.
on several websites, and currently I'm working with Talendy, which is a company based out of Japan. And we have designed a system that basically helps um, students from tier one colleges to find internships overseas. So here we had to understand both the context of recruiters from the Japan side and the context of students from the Indian side. And then we had to find a design which bridges both of these things, right? Because there's a cultural mismatch, there's a communication mismatch, there's also a protocol mismatch because both of these environments work very differently. And when we bring them together, we have to bring them together in a way that it serves the purpose, the user's needs are met, and the business is also profitable at the same time. So this is one of the projects that I've been working on. Apart from that, there are several other projects that I've done, but those are more or less for my own thing. So yeah, I think that's the main project that I'd like
You
to
are
talk
now
about.
unmuted.
To learn HCI? Okay, so I think
You
the
are now
first thing I
muted.
would suggest for anybody who's trying to learn HCI is that start looking at everything around you. There's design in everything. Sensitize your eyes towards whatever you are seeing. Every time you use a good design and it feels invisible to you, try to understand why it feels that way. Or anytime you get frustrated while using an application or a product, try to understand why it's frustrating you. The second suggestion that I would give is that I think every engineer should also understand the basic principles of user experience. You can read this book called Design of Everyday Lives. It's by Norman, so Dr. Norman. It's a very good book, and it talks about how bad designs can really disrupt our everyday lives, and how good designs are not even visible because they are so seamless. So I would encourage everybody to learn the basic principles of UX design, why it's so important. There are certain laws to it. I would ask you and urge you to look at those laws. And it's not just for designers, it's for everybody who's trying to interact with technology and trying to do something with it. So that's my suggestion. And lastly, I think there are several courses online. If somebody is very interested in HCI, there are some free courses as well as some paid courses which really help you get to the crux of it. But for starters, I would just suggest that, uh, try to read about HCI and about UX design. There's plenty of material on the internet, on YouTube. There are plenty of articles. And I'm sure if you take 1 month, you will be so much better off.
You are now unmuted.
Thank you so much, ma'am.
Thank you so much. It was wonderful to be here. Thank you. Have a great weekend.
Thank you.
Bye bye.
You are now unmuted.
Our next session on future of AI in infrastructure and risk management will begin at 7:15. Please stay tuned.
You are now muted. You are now unmuted.
Thank you for patiently waiting, everyone. So, our final keynote of the day is delivered by Dr. Hooman Razavi, Research Assistant in Engineering Science at Tecnologico of Monterrey, Mexico, and visiting scholar at the University of Ottawa, Canada. Today, we'll give the keynote on future of AI infrastructure risk management. To tell you more about the speaker, Dr. Razavi holds a BSc in computer science, in computer engineering, and MSc in artificial intelligence, a DBA, and a PhD in engineering science. With over 12 years of experience in fintech and IT, he has worked as an AI developer, data analyst, business manager, and a consultant. He has lectured at University Canada West and taught IoT for the UN Institute of Training and Research. His research and publications span applied AI, fintech, and risk management, and he serves an editorial board such as the International Journal of Cybersecurity and Risk Assessment. He also reviewed for leading journals including IEEE Transactions on AI, Expert Systems with Applications, and Applied Soft Computing, in addition to serving on technical committees for top AI conferences like ICLR, ICML, and uh, Neuro IPS. Today he will present future of AI in infrastructure risk management. So over to you.
You are now muted.
Hello, everyone. Could you hear me?
You are now unmuted.
Yeah. Shall I open my video or not? Yeah.
You are now muted.
Yeah, I have opened my camera. And also, let me share my slides to start. Can you see the slides?
You are now unmuted.
Yeah.
You are now muted.
Thank you so much. I'm so glad to be in this session, and it's very appreciated to onboarding me. Today, I am talking about risk management and risk assessment using artificial intelligence in cyber infrastructures. My presentation has two parts. The first part is about a product we developed in universities, and I want to show that how our science transformed to a kind of technology and how we can use this technology in the industries with a focus on banking industry. And the second part is about our last publications in this field. Abacus is a software for estimating the financial cost and the risk associated of cyber attacks based on business pattern activity reconstruction, and we are using artificial intelligence to risk assessment in cyber security attacks. About me, as mom said, my education was in computer science, computer engineering, and I have two PhD in engineering science and a doctorate of business administrations. I am working with University of Ottawa and also Tecnologico de Monterrey in Canada and Mexico. And I am working with IEP company and also York University in Toronto. I have experience as a CTO and co-founder at IEP Canada Incorporation, and I worked as a digital business analyst at two large-scale banks in the Middle East with 8 years of experience as a data scientist and AI developer, and also a lecturer at University Canada West and Shomal University, with some publications, books, and many interviews. And also, I am serving as a reviewer and some top tier journals, and also as an editorial board in journals. About the market, if we want to talk about the market of cyber risk and risk of infrastructures in cyber business, we have a risk around $250 billion a year associated with global cybersecurity market. This is the amount that institutions and companies around the world are investing and spending for their cybersecurity issues. It's about the cyber attacks, softwares, human resources, and maintenance of their infrastructures, both in software and hardware sides. And also, there is a big unlocked target market for cybersecurity and cyber risk infrastructures. The risk like downtimes, missed transactions, lost opportunities of business during the cyber attacks, during the cyber risks, and during the outage of services. So if I want to outline the problem is about, first is it's hard to quantify the loss of business opportunities during cyber attacks. The second one is accuracy during operational risk assessment, because in last years, in the recent years, a lot of businesses came to be a kind of digital businesses. For example, banking institutions, insurance companies, e-commerces, and all of them are operating on a cyber infrastructure. So their operational risk is associated to the cyber risks. Estimating the demand from the customer side during the downtimes and attacks is hard to identify. And the fourth big problem is designing a suitable SLA, service level agreement, between service providers and consumers. So our solution is answering these four questions: detecting cyber attacks, detecting cyber incidents, estimating the lost opportunities, reconstructing the business activity patterns during the downtimes, and the last one is calculating the cost of cyber risks. Let's see our software background. In the background and in the backend, we have some data sources, transactions, and consumer behaviors as a data. We do a kind of ETL on the data for extracting, transforming, and loading data to the databases. Use a data warehouse to gathering data together, and also a data analytics. And in the core of our software and our project, we are using a deep learning method to estimating the business pattern activity and calculating the cost of cyber risk and cyber attacks. And also we have a kind of dashboard for business intelligence to the end users. Let's see some examples. In the left figure, green figure, I mean, you can see the transactions of a large scale bank in the Middle East. The x-axis is about the hours of the day, and the y-axis is the number of transactions. And you can see two peaks in two times. I'm not sure about the fintech and banking transactions in India or other countries, but at least in the Middle East, we have this pattern activity for banking consumers and banking and payment transactions. You can easily find that between hours 9 to 11, 9 to 12, we have some kinds of interruption in the services because of cyber attacks and because of outage of the infrastructure. And finally, our software could estimating the pattern of business and pattern of behavior of the consumers, and we could find the missed transactions, the missed business opportunities during that time. And with some kinds of figures, we identified the lost business opportunities and also calculating the operational risk associated to the cybersecurity. So with this simple solution, we can use artificial intelligence for risk assessment in cyber infrastructures, but this project take a decade of time from expert teams to do this. And we implemented this solution in 20 banks in the world. What is the value proposition? First, for the financial institution, enhance risk management, operational efficiency, customer trust. For the society, quality of service enhancement, innovation and growth, and customer protection. For insurance companies, this is a tool for risk assessment, enhanced product offering, and the efficiency regarding the claims between consumers and service providers. Our tool can find and can calculate the SLA, the service level agreement between consumers and the service provider. And also this has a lot of values for regulators. For example, enhanced monitoring services, compliance reporting, and proactive risk management. I talked about market. We have a total potential $10 trillion market annually, and it's growing because every day more businesses become digital and relying on infrastructures like softwares, like networks, and other cyber infrastructures. So the market is growing, and you can see the most biggest market is in North America and also Europe, because in these regions the most businesses are digital, and we have some markets in Middle East, Asia Pacific, and other regions. About the existing solutions, we have some other solutions in the world. For example, RiskLens, GRX, UpGuard, Safe, and other companies are working in this area, but their approach is a little different with us. We are using artificial intelligence, deep learning methods for the estimation. It's different to some qualitative methods to risk assessment. And let's see our software. are played and run the software for you. You can see in this video, this software is working with data. It's a kind of MVP, minimum viable product, filter transaction in seconds and minutes. Let's run again. Yeah. And we are working to rebuild fundraising, expansion the market, and scaling to other markets, both in the geography. We are working to expand our business and our product that is a fully scientific based product. We prepared many papers. It's important for you as young scholars to know that every one of you can turn your scientific papers or your research to a meaningful project, and seeking for fundraising, seeking for someone who may be interested in your project, in your research paper, to expand your market, to implement in the real world scenarios. And the second part of my presentation today is about our publications. In 2023, we published a paper quantifying the financial impact of cybersecurity attacks on banks with my teams from York University, University of Monterrey, and other universities. Yeah, this is the network architecture of banking network. You can see in the picture we have some devices, for example, mobile devices, web services, POS, ATM devices, as you have in your country. And there is an infrastructure for handling and routing the transactions. It's called switch networks, and a core banking system for handling the transactions. We use this kind of methodology, data collection, analyzing the data every day by day, and finding the DDoS attacks, and checking our attacks as we find with our AI systems, with the experts in the financial institution, and also calculation the loss. These are you can see the data types we used. We analyzed 33 billion of transactions. 33 billion of transactions, really huge data in terabytes text data of transactions. Banking transactions are using and are following a specific standard for data data recording. The standard is ISO 8583. You can see the main important fields: date of transactions, arrival time, reverse time, terminal types. I mean, for example, ATM, POS, and other type of terminals. Code of error, service types, and transaction amount. Amount of transactions is important for calculating the cost and the fees associated to the transactions, for calculating the risk and operational risk assessment. About the result, in the upper figure, you can see the trend of increasing transactions. As I mentioned before, every day businesses are becoming more digital, and digital transactions, digital banking is growing. And you can see from 2018, for that bank in the Middle East, from 2018 to 2022, it is an increasing trend in the transactions. And you can also see in the bottom figure the distribution of transactions, most of them are POS, terminals, point of sales. And after this, ATM withdrawal, ATM transfer transactions. And we worked to identify the type of transactions. You can see in the figure, POS has the bigger portion of the transactions, ATM, and also internet and mobile transactions. In the Middle East, POS is pioneer in transaction occurring. And for each type of terminals, we identified the kind of transaction, the type of transactions. For example, withdrawal, transfer, charge, balance. It's important to use a kind of expectation value and mathematical expectation value for identifying a typical transaction, to knowing better the behavior of consumer, for calculating behavior of consumer and estimating this behavior during the downtimes. Also, these are some histograms of amount of transactions in, I think that in US dollars. Yeah, you can see a pattern like a normal distribution for POS and ATM, but for internet and mobile, we have a kind of exponential distribution for our transaction amounts. All of them are statistical works on big data to finding the consumer behavior. So I have a table for mean and median of transaction in US dollar in that specific country. It's not this is specified to a kind of region and country. It's not expandable to other countries. For each country, we should have the data and working statistical works. We find the probability of transactions. You can see in the first column. And in the last column, we calculated the expected income of each banking transactions. So from here, we used AI. Our deep learning model applied to this TPS figure. You can see in the left hand, and in the right hand, it's a zoom of left one. You can see our model. Please follow the yellow line. This is the output of our deep learning model to estimating the lost transactions during the downtime. And we found 21 minute downtime and around 500, more than 500,000 transactions lost during the downtime. It's a huge amount of transactions for a banking institution. And other results, the key finding I have mentioned before. Let's go to the, it's important for young students how you can expand this research, because I am available to work with you young researchers. You can reach out to me to talk about the future research direction and work on papers with your professors, with your young scholars. For future research directions, we have some areas. Comprehensive cost analysis. We can add some other cost analysis. Consumer behavior analysis could be more accurate. Enhanced cybersecurity strategies, and also the role of cyber insurance. It's more important because we can expand this work to find a kind of framework for the future insurance companies to ensure the risk of cyber attacks. Our second paper, we used large language models, LLM, for estimating the cost of cyber attacks. Let me go through the slides. Yeah, in the introduction, we have some statistics regarding the financial cost of cyber attacks in different industries. For example, the most cost is in manufacturing, and the second high important market is finance and insurance industries, and the most reason is leakage, and the second one is disruption of services. In Europe, you can see the cost of cyber attacks for companies in the Europe. You can see this is a increasing trend, for example, in the UK and also in the Netherlands and Belgium. This is our data I explained before. And about the methodology, we used large language models for time series forecasting in this paper. We applied the model for forecasting time series, and after data preparation, we applied LLM and also big data analytics, and with big data analytics for insight generation and cost estimation about the value of transactions, and large language model for finding the number of lost transactions, and by combining these two insight, we can calculate the cost. Or LLM, we use this LLM and token and analyzes the token for forecasting the time series of banking transactions. We wrapped and concatenated the days after days to shape a signal of a time series signal for banking transactions, and use our LLM for anomaly detection. Let me go through the results. Yeah, you can see a comparison between different methods, LLM, deep learning, and SVM, and you can see LLM can outperform both in the time consuming and also in the accuracy against other methods. Actually, this paper significantly contributes to quantifying the cost of cyber attacks, and we used edge technology like LLM to quantify the risk, and compared with other machine learning techniques, the performance of LLM was better. And also we can work together to expand these results to the insurance companies, and also analyzing the consumer behavior in other aspects. For example, during attacks and during downtimes, we have no information regarding the behavior of consumer. For example, if we can analyze the call center data of consumer in other platforms for payment, we can have a better analysis of their behavior. And this is my last slide. In this day, I published 2 books. The first one is with CRC Press, AI-driven cybersecurity, with my co-editors, and AI-driven cyber risk management. This is my latest book, published with River Publisher and IEEE publications. And we are working on these topics more and more. We are working on some papers that could be published in 2025, and also we are working with on some books. I am collaborating with your professors, for example, Professor Kishore. I am working with him in some research areas, and I would be glad to expand our collaboration with your university and your network to do better. Thank you so much. This is my uh, contact info, and I would be more than happy to have a conversation with you all. Thank you so much.
You are now unmuted.
Excuse me, mention about what? Uh, Excuse me. Where you want I talk more? I couldn't hear you correctly.
You are now muted.
Could you hear me?
You are now unmuted.
Abacus, yeah, yeah. Abacus is it? Yeah. Let me share again with you for sure. For sure, I will explain Abacus. Abacus is software we developed based on our research. This is a software for estimating the financial cost and also risk assessment of cyber attacks and cyber downtimes in industries, specifically in banking industries. For example, when a bank in a country is facing a kind of cyber attacks or cyber downtime because of, for example, power outage, a storage outage, downtime of CPUs, infrastructures, the bank is facing cost regarding these incidents. Our software can calculate this cost. How many business opportunities, how many consumer you lost during the incidents. And yes, these are our figures from our BI dashboard that we presented to the banks for calculating this cost. And also we have written some papers and books regarding our work. It has two sides, a side of scientific and a side of technological and software development and implementation. Okay.
You are now unmuted.
Yeah.
You are now muted.
Yeah. Is there any specific question?
You are now unmuted.
The application of this research is we can
You are
use
now
this
muted.
software and this research in other industries. We just test financial institutions, banking institutions, insurance companies, but we can expand these in any cyber infrastructures. For example, traffic cameras, for example, e-commerce services. You can imagine that if a e-commerce service in your country faced a damage or faced a downtime in the infrastructures, the e-commerce will lost a lot of opportunities for selling and buying something. Who can calculate this cost? Who can write the service level agreement between consumers and service providers? Who can manage the cost? We need a software, we need a solution to do this. We need a third party, a kind of regulation technology to calculate this, and this is our work. We are working to expand this work both in scientifics. We can use more advanced technologies to more accuracy in pattern recognition, and also we can expand in another countries and in other industries. This is our works in last recent years, and we are continuing this work.
You are now unmuted.
Thank you so much. I am available for every student, every
You are now
professor can reach on me. Dr. Kishore has my WhatsApp number and also my email. I am available. If everyone can reach me, I am glad to expand our collaboration more and more and take participate in your next sessions and for next year and this year. Thank you so much. It's a great work with Stanley University and Professor Kishore to preparing these meetings and inviting me. That was a great pleasure and hope you the best. Thank you.
You are now unmuted.
Yes, sir. Thank you once again for taking part in this. So, and thank you to the audience for joining the sessions. And tomorrow we will shift into panel discussions featuring multiple voices and perspectives on the future of engineering. Until then, thank you. Have a wonderful evening.
You are now muted.